I'm live. Yeah, all right. All right, hello guys. Welcome to this session, number system in one shot. All right, so who's here with us? Darsh says he's really enjoying the classes. I'm really happy to know that. All right, so we have Saranya here, we have Dipesh, we have Archit. Rafiq says I'm perfectly audible and visible. Thank you for that, my friend. We have Archit, Jay Gulati, good afternoon. Shanmugam, he's quite curious today. Prashansa says hello, hi, Prashansa. All right, we have Vimlesh here, hello. We have Debu, hello. Charan, Preeta, hi. I'm doing good, Archit. I hope you're doing great as well. Same to you, Rafiq. All right, so we're doing pretty good today, yes? All right, I'm doing great, you know. Techno Gamers. I would love it if you can tell me your real name. Techno Gamers sound kind of odd. Saranya, very excited. Okay, glad to know that, Saranya. All right, so in today's session, what we're going to be doing is, this is the first chapter from your grade 9 math, right? The number system. We would try to complete all the concepts from this chapter to, wrap whole things up, giving you a nice revision as we flow into the next topic. All right, and the next chapter that we're going to be starting after this is going to be polynomials. So today, we will revise all that we have already covered. All right, so come on, let's begin now. Now, I would like to start today's session by talking a little bit about the BYJU'S classes 2 teacher advantage. Now, there are plenty of advantages that go along. The first one being that, these classes are going to be mapped to your school curriculum. You can choose your own class timings, whichever way you are comfortable. Personal attention would be given to you. There will be one-on-one guidance from a personal mentor, and these are all personalized. Because guys, look, there are plenty of teachers out there who can simplify a concept and teach you in the best way possible. But what makes a true difference is having a one-on-one mentor. All right, because while you are listening to a concept, it is quite natural for you to have many questions pop inside your head. All right, and some of these ideas may be really brilliant, but if those questions go unanswered, all right, that doesn't do much to your confidence level. So this is the reason why I'm a big fan of this two-teacher model, where one teacher is explaining the concepts and you simultaneously have another teacher who's ready to take care of all of your doubts. Because when your doubts get clarified, that is when your confidence rises. And you never know, some of the concerns and doubts you may have, doesn't matter how fundamental they are, but they may be quite brilliant as well. All right, so this is the reason why I am a huge fan of the BYJU'S classes 2 teacher advantage. Now do check it out. Starting packages are as low as 199, and the link to this could be found in the descriptions box. All right, so come on, moving on from this to the Telegram channel. In case we have any new students joining us through this video, there is a Telegram channel that we operate. Again, you will find the link to this in the descriptions box as well, because quite important for a lot of reasons. First and the foremost being the session notes with the teacher's handwriting. This would be shared on the Telegram channel, apart from all the other updates like the session updates, if there are any changes in the sessions, the revision questions, homework questions, quizzes, all of this would be part of the Telegram channel. So please make sure you join the channel. The link to this could be found in the descriptions box. All right, so come on, let's begin today's session now, and that is going to be number system. So first thing in number system that you've got to know is that we're dealing with real numbers here. All right, so real numbers can be broken down into two major categories. All right, real numbers can be broken down into two major categories. The first category being rational numbers, and the other one being irrational numbers. Now we've studied what rational numbers are, right? So what are these rational numbers? These are numbers that can be expressed in the form of a fraction. Let me just go ahead and write x by y, because sometimes my a looks like a 9. All right, so these rational numbers can be expressed in the form of a fraction, x by y, where both x and y are going to be integers. All right, and of course the value of y cannot be equal to 0, because division by 0, as you guys know, is not defined in mathematics. So rational numbers can be expressed in the form of a fraction, which brings us to irrational numbers, and these are numbers which cannot be written in the form of a fraction. So let me just write that down here. Cannot be expressed as a fraction. All right, so far the definitions are fairly simple. Rational numbers can be written in the form of a fraction. Irrational numbers cannot be expressed in the form of a fraction. And under rational numbers, you have many categories that you guys have covered. Like you have whole integers, first thing, right? Now you know integers are positive and they are negative integers as well. So what are positive integers? 1, 2, 3, and you know they go on and on and on. You've got negative integers, -1, -2, -3, that goes on and on and on. 0 is going to be an integer, but as I always say, this is really important. It's neither positive nor negative. Under integers, you have whole numbers. What are whole numbers? 0, 1, 2, 3, and again, they go on and on. And lastly, under whole numbers, you have natural numbers. So natural numbers are going to be accounting numbers, 1, 2, 3, 4, on and on, right? And some examples of irrational numbers that I could give you is pi. Root 2 is an irrational number. Root 3 is an irrational number. Root 5 is an irrational number. All right, well done. Come on. So we've understood what rational numbers are. We've understood what irrational numbers are. In this session, we will also go ahead and check out how you will be able to plot these rational, irrational numbers on a number line. And I have something which is pretty exciting in this session that we couldn't do in the earlier sessions for some reasons. All right, so moving on from this. Again, you have equivalent rational numbers, right? So these are again fairly simple. The example here, pretty much explains it all the way. Now you know this, 1 by 2 is going to be equal to 2 by 4, because 2 by 4, when you remove the common factors between numerator and denominator, it becomes equal to 1 by 2, right? Like 2 divided by 4. 2 can be written like 1 multiplied with 2. 4 can be written like 2 multiplied with 2. So these two common factors will get cancelled, and as you can see, this is again equal to 1 by 2. A similar thing with 3 by 6, 4 by 8, 5 by 10, 6 by 12, 7 by 14, 8 by 16, it goes on and on. All right, so you've understood what equivalent rational numbers are as well. Now moving on from this, now here's a question based on the concept that we've just covered. Which of the following is the equivalent rational number of 16 divided by 28? Options are, this is 4 by 7, then you have -4 by 12, 5 by 7, and -4 divided by -12. Go ahead and tell me the correct answer. All right, Saranya says it's going to be option A, which is 4 by 7. All right, so all of you are agreeing. You know, we've got Zarina, Shruti, Aditi, Satish. All right, names are flowing by pretty fast here. Apologies for not reading out your names out there. All right, so pretty much all of you are saying that option A here is going to be the correct answer. Well done. It is going to be the correct answer, because 16 divided by 28. 16 can be written like what? 4 multiplied with 4, and 28 can be written like 4 multiplied with 7. So as you can see, both the numerator and denominator have 4 as a common factor, which I can cut it out, and as you can see, it simplifies itself to 4 by 7, making option A as the correct answer. Well done. Well done. So we've seen what rational numbers, what irrational numbers are. We've seen equivalent fractions, and you've also answered a question on the basis of that. So let's move on to the next concept, which is going to be, yes, it is just a good thing to remember for you, right? So two positive numbers A and B, if AB is not a perfect square, then square root of AB is going to be an irrational numbers that is lying between A and B. So using this, let's go ahead, answer a question. So which of the following is an irrational number between 5 and 10? So you can assume this to be A, you can assume this to be B, and you've just seen that irrational number between A and B can be written like square root of A multiplied with B. Granth, I've taken your name now. Yes? So again, the answer to this is also going to be A, like a lot of you are saying. Yes? A looks like it, right? Square root of 50, because between 5 and 10, 5 multiplied with 10, so there you go. This is going to be square root of 50. Well done, well done. This is going to be the correct answer, as I will just show you in a bit. That's it. So we've covered two really good concepts. Now let's go ahead and revise the decimal expansion, because remember guys, this session is going to be really helpful when you are trying to revise the whole chapter in 40-45 minutes for your exam. So please pay attention. Decimal expansion now. All right, so you've seen these four categories, right? Terminating, you have non-terminating, you have recurring, and then you have non-recurring. Let me give you an example for each of these categories. First one, a terminating decimal. Terminating decimal, an example being 0.75. As you can see, it terminates, it ends, the decimal part ends at 5 here. Non-terminating, which means it goes on and on and on and on. Something like 0.8592, on and on and on and on. All right, so this is going to be non-terminating, which means the remainder never becomes 0. It goes on and on and on and on. Recurring means it is going to be non-terminating, right? But you will see a recurring pattern. An example could be 0.7858585. So the recurring pattern here is going to be 85. So in terms of bar, I can write it like this. I can put a bar on top of the digits 85 to signify the fact that they are recurring or repeating. Non-recurring is going to be what? Let's say 3.1428976, on and on and on and on. You don't see any recurring pattern in it, right? So Utkarsh has an answer 0.121212. Well, this is going to be what? 2 digits are recurring or repeating, right? So that is going to be a recurring decimal. But you've got to put dot 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 to signify that it is non-terminating. All right? Cool. Come on, let's move on. There's not going to be any Menti quiz on that, so you should come on, let's move on now. Classify the following decimal expansions as either terminating or recurring. Come on, go ahead and answer this question. Yes, Shanmugam, pi is non-recurring, of course, and it is non-terminating as well. Yes, terminating means ending, recurring means repeating. Well done, Zarina. That's correct. That's correct. All right, so the first one, 1.568972. As you can see, this is terminating. Well done. So let me just grab a better color for this. So this is terminating. Terminating. Well done. Since this is ending there. Very good. So the first answer is terminating. Very good. What about the second one? You just have to decide if this is terminating or recurring. That's it. The second one is what? 935, 935, 935. Well done. This is going to be what? A recurring decimal. Very good. What about the third one again? Third one also is going to be recurring, right? Right? Look, 2, 1, 2, 1, 2, 1, 2. Let me just, yeah, so this is going to be recurring again. And the last one, as you guys have understood it by now, it does not recur. So this is going to be terminating. Very good. But if we were to write this in the form of a bar, this can be written like what? I'm writing it on top here, 1.935, and I'll put a bar on top of the digits 935 to Snehdeep. Look, I've taken your name, terminating last one. Yes, Snehdeep Kaur. 1.935, you put a bar on top of the digits 935 to signify the fact that they are repeating digits. And now when I look at this, this is going to be what? 1.212. So I'll put a bar on top of 12 to again signify that those are the digits that are repeating. So we've understood these things, right? Fairly simple, very basic. We now know what is terminating, we know what is recurring, we know what is non-recurring, and we know what is non-terminating. Right? Come on, let's move on now and check out the other examples. Okay, so decimal expansion of real numbers. So here's the first thing that I'm going to check out, terminating. Right, we've seen it. The remainder becomes 0 after a finite number of steps. Here you have an example for this. And then non-terminating. Non-terminating means what? You've seen it. The remainder never becomes 0. Okay, so you've got to know this, right? I am going to write it down here. Rational numbers are going to be, if I were to give you a definition in the form of decimals, they are going to be terminating, and if they are non-terminating, it's fine. It's fine if the decimal is non-terminating, but it has to be a recurring decimal. Okay, so both of these come under the definition of rational numbers. So terminating decimals are rational numbers, non-terminating recurring are also rational numbers. Whereas non-terminating, non-recurring, they are going to be irrational numbers. I'm writing that down here. Irrational. So this is going to be non-terminating and non-recurring. You have already seen the examples for this, pi, √3, √2. We've also shown you an example here. Yes, Vimlesh, I have taken your name now. All right. So We're clear with these decimal expansions for these as well. So what I'm going to do now is just first go through an example, and then I will take you that visualization that I was talking about, okay? So which type of decimal expansion is the following number? So you have to decide, is this terminating, or is it non-terminating, or is it non-terminating and recurring, or non-terminating and non-recurring? All right, so what is the difference between rational and irrational numbers? Rishika, we've seen this in the initial part of the session. Rational numbers can be expressed in the form of a fraction. Irrational numbers, you cannot write it in the form of a fraction. All right, so all of you agree that this is going to be D. Let's go ahead and check out the answer. Well done. As you can see, dot, 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 dot means it is non-terminating, and you can't even see any pattern of digits which are repeating. So well done. All right, so come on, pay attention to what we're about to do now. Okay, so this is the part where we talk about how to plot these rational and irrational numbers on a number line. All right, so first we're going to look at rational numbers. I'm going to start with an easy number like 1 by 2. Okay, so look, this is how you will represent 1 by 2, right? 1 by 2 is going to be between 0 and 1. Yes, and then it moves on like this. This becomes 2 by 2. Then this is 3 by 2, 4 by 2, 5 by 2, 6 by 2, 7 by 2, 8 by 2. You see, it moves on like this. Yeah? Okay. Now what will happen if I make the fraction as 1 by 5? This is important, okay? Let's suppose you want to plot 1 by 5 on a number line. What you've got to do here is 1 unit. Okay, 1 unit, you can consider it to be between 0 to 1, 1 to 2, 2 to 3, 3 to 4, something like that. You have to divide that in 5 equal parts. Why am I dividing it into 5 equal parts? Because as you can see, the denominator here is 5, and you can count it. Look, let's just take it to the left. Right, so this is going to be 0 by 5. Then I'll keep moving on. 1 by 5, then 2 by 5, 3 by 5, 4 by 5. 5 by 5 is nothing but 1. That's the reason why, as you can see, the arrow is pointing at 1. Then what? 6 by 5, 7 by 5, 8 by 5, 9 by 5. Yes? And 10 by 5 is going to become 2. If the denominator is 7, what do? If the denominator is 7, you will divide 1 unit, okay, into 7 equal parts. And then it moves on like this. 0 by 7, then 1 by 7, then 2 by 7, and then what? 3 by 7, 4 by 7, 5 by 7, 6 by 7, 7 by 7. This is how it is going to move on. Okay, now let's check how do you plot irrational numbers on a number line. All right, now let's start with 1. Yeah, 1 is going to be very simple on a number line. Now if I move on and I try to check out square root of 2, this is how you will plot square root of 2. First thing that you would do here is right angle triangle. Okay, you all remember the Pythagoras theorem, right? The sum of the squares of the base and the height is the hypotenuse, right? Under square root, of course, Pythagoras theorem. So when this is 1, as you can see, the hypotenuse of this triangle is root 2, right? Because it all starts with root 2, guys. If you know how to plot root 2, you can plot any irrational number on a number line. Okay, so you take a scale. The horizontal distance here is 1, as you can see, and then you will draw a perpendicular 90 degree, and this will be 1 as well. Okay, let me just draw it out and show it to you. Okay, look, how to plot root 2. First, what you are going to do here is, let's say this is you've drawn a line first, all right? Let's say you have taken a scale and made some measurements. Let's say this is 0, this is 1, this is 2, this is 3, this is 4, this is 5, let's say in centimeters, all right? So you've done that. Now what you will do here is first take this measurement as 1. All right, so how much is this? 1. And then from this point you will draw a 90 degree angle. 90 degree angle, you can do that using a protractor, and again measure the same one. Let's say if this is centimeters, this is also going to be in centimeters. And when you join these 2 points, this becomes root 2, right? As per the Pythagoras theorem. And now what you will do here is draw an arc, and that arc here will cut this line at a point, and this complete distance here is going to be root 2. Okay, I am going to talk about the spiral method. All right, I'm going to show you the spiral method now. So that is root 2. What about root 3? Root 3 is going to be what? Look, root 3 is going to be, this is root 2, this is 1, this will be root 3. Always remember the height of the right angle triangle will always be 1. All right. And then root 5 will be what? Root 5 will be, this is 1, this is 2. Then root 7 will be what? Root 7 will be, this will always be 1, this will be root 6. So this is how you will build it. And now I'm going to show you that using the spiral method. Okay, check out the spiral method. All right, so first thing, what do you have here? This is going to represent this 1, right? Now look, AC is root 2, by the way. Yeah, so look here, AC is going to be root 2. From this point C that you see, you will draw a perpendicular of height 1, then AD will become root 3. Like that, if you keep moving on, you get this spiral. Okay, this is what I wanted to talk about. This is something new for us. Look, I'll explain this again for you. AC here is root 2. You have already seen how to draw root 2. Now from this point C, you will draw a 90-degree angle of unit 1, okay? And then this AD will become root 3. Then AE will become root 4. AF will become root 5. AG will become root 6. So you see, this is how it moves in a spiral. Yes, Shivansh. All right. So this was the spiral method. You start with root 2 and then root 3, root 4, root 5, root 6, and it moves on and on and on. Okay, look, it's very simple. I'll try to explain this again for you. Please focus. This AC here is going to represent root 2. Okay, AC is going to represent root 2. From this point C, you will draw a 90-degree line, all right, of unit 1. Then AD, when you join these 2 points, CD here is 1. Okay, AD will become root 3. Then again from D, you will draw a line, vertical line at 90 degree, 1 unit. Then AE will become root 4. Okay, and then again AF will become root 5. AG will become root 6. Like that, it will keep going on. Okay, and this is how you get a spiral. So you have to look. You have to try this out on your own. Any construction that you have to do, right? Unless and until you take a paper and pen and you know, start practicing using these very basics. That's it. You're not using any rocket science here. You just have to remember the Pythagoras theorem and the fact that the height of the triangle that you're taking always have to be 1. So that's it. These are the basic fundamentals that you've got to know on how to plot an irrational number on a number line. All right, so come on, let's move on now and check out some other ideas from this chapter. Operation on real numbers, this is again simple. Rational plus irrational, you know, we have already studied this. I don't have to really take this in enough depth. Rational plus irrational or minus, multiply, divide is always irrational. But when you repeat the same ideas on 2 irrational numbers, the result can either be a rational number or it can be an irrational number. Okay, why? Okay, Shanmugam, why do you want to take 1 as a height? Because it's easy. That's it. It's easy for you to draw a vertical line of 1 centimeter rather than drawing a vertical line of root 2 or root 3. This is the reason why. Okay, simple logic to make your life easy in terms of constructions. How to find irrational number, how to plot irrational number. That's about it. Look. As long as you know how to draw root 2, right, you will understand how to plot any irrational number. Look, first thing that you have to do is root 2. If you know root 2, you know everything. So root 2 means what? Right angle triangle, hypotenuse every time. Hypotenuse is what we are plotting. So hypotenuse is root 2 automatically means the base is 1 and the height is 1. Because that is when you have 1 square plus 1 square under root as root 2. So this is going to be 1. And then from this point, you will draw a vertical line, same, okay, this is 1 centimeter, this is 1 centimeter. And when you join these two, OA, let's say, this becomes root 2, all right? And now what you need to do here is take a compass, keep the pointy edge of the compass on O, measure OA, and then keep the pointy edge on O and draw an arc. When you draw an arc, it will cut the number line at this point, B, let's say. Then OB here is going to be root 2. That's it. If you know root 2, you know root 3, you know root 4, you know root 5, you know root 6, you know any irrational number. Because this is how the pattern goes on. For root 3, if this is root 3, this has to be 1, this has to be root 2. You already know how to do root 2. If you want to do root 5, This has to be 1 and this has to be what? 2, right? If you want to know root 7, always remember height has to be 1 every time, because that is something you have to draw using a ruler. Then this will have to be root 6. So like that, you want to plot 7 on a number line. Yes, this is the example. Look, you first plot root 6. And from there, you draw a vertical line 1 centimeter long. I'm assuming the units that you're taking is centimeter. And then automatically the hypotenuse here is going to be root 7. Yes, root 2 plus root 2, 2 root 2. Yeah, it can be, as I said, two irrational numbers can be irrational or they can be rational as well. What could be a good example for rational? 2 plus root 3 plus 2 minus root 3. In this case, you see, it will become 4. So they can be rational, they can be irrational. I hope, Aditi, you have understood it. Root 13, how would you root 13? This has to be 1. This has to be root 13, which means what? This has to be root 12. So first you need root 12 and then you will do root 13. Okay, if you want to go by the method which is prescribed in the textbook. But if you want to go in approximate method, look, you don't need that much drama, right? You know root 9 is 3. You know root 16 is how much? 4. So you know root 13 is going to be lying between 3 and 4. Approximately you can say that, yeah, it's going to be 3.5-ish, 3.6-ish. Okay? Irrational plus irrational is rational. Look, here is an example. Let's say an irrational number is 2 plus root 3. Why? Because rational plus irrational is always irrational. Plus 2 minus root 3. Rational minus irrational is again irrational. Add them up, what do you get? Plus root 3 minus root 3, 0. 2 plus 2, 4. Okay. Root 17. Come on, think about it. Why aren't you guys using your mind? Think about it. Root 17 will be what, Arunima? Root 17 will be the hypotenuse. It means this has to be 1, this has to be 4. Because 1 square plus 4 square under root is 1 plus 16, which will give you root 17. All right. Okay, cool, awesome. Now let's try and solve this question here. Root 4 plus root 3 plus root 4 minus root 3. What is going to be the answer for this? 4, like you guys are saying, very good. Because root 4 we know is 2 plus root 3. We will leave root 3 as it is. Then this again, root 4 we know is 2 and then minus root 3. Now you know root 3, I can combine these two. I can write 2 plus 2 here plus these two together. Root 3 minus root 3. You know root 3 minus root 3 is 0. So this is 4 plus 0 and that is how you get 4 as the correct answer. So this is fairly simple. Yes? Come on, let's take another example now. Alright, so this is in the form of a plus b whole square, a minus b whole square. What is going to be the correct answer to this? So a plus b whole square. This is, as we know, a square plus 2ab plus b square. And then a minus b whole square is going to be a square minus 2ab plus b square. Alright? Darshan, what time the classes would be there? As I said, if you're talking about the BYJU'S classes, you can leave the comments and then somebody will get in touch with you. All right? Come on. How do you do this? Expand this using the a plus b whole square formula. So this is going to be 2a square plus b square plus 2ab, right? And then you have to add a square plus b square minus 2ab, right? So this is going to be what? When you add them, 2 square plus 2 square is 4 plus 4, 8, plus root 3 square is 3, 3 plus 3 is going to be 6, this and this is going to be cancelling out, 0. So 8 plus 6, what is the answer going to be? Very good. The answer here is going to be 14. 14. Because 2 square is 4. 4 plus 4, when you add these two, you get 8. All right. Same session on other chapter. We will, of course, Vedika, we will. So 14 is going to be the correct answer, like you guys are saying. Well done. So we've understood this as well, right? Non-terminating decimals are recurring decimals. Non-terminating can be recurring, they can be non-recurring as well. When they are recurring, it is rational. When they are non-recurring, they are irrational. 6, how did 6 come? Okay, root 3 square is how much? How much is root 3 square? Root 3 square is going to be 3, right? So root 3 square plus root 3 square. How much is this going to be? This is going to be 3 plus 3. And this is how you're getting a 6. Yes? So you see how important doubt clarification is. Yeah? It is not just enough to teach you a concept. Because teaching, as I said, anybody can do it. What's more important than teaching is clarifying your doubts. Because only when your doubts are clarified, you become confident in a topic. All right. Come on, let's move on now and check out the other part of this chapter, because this is quite a lengthy chapter. There are some quite a lot of topics here. So we are familiar with the technique of rationalization, right? So all you have to worry about is if the denominator has c plus d, you will multiply and divide by c minus d. But if, let's say, the denominator is c minus d, then you multiply and divide by c plus d. Okay? That's all. Awesome. Cool. So let's use this technique of rationalization now to solve some questions. All right. So how am I going to rationalize this? 4 plus root 3 divided by 7 plus root 3. So 4 plus root 3 divided by 7 plus root 3. So in the denominator, I have 7 plus root 3. So I'm going to multiply this with 7 minus root 3 and also divide it by 7 minus root 3. And now it is as simple as multiplying two fractions. So I'll multiply both the numerators. 4 plus root 3 multiplied with 7 minus root 3. And now the denominator is going to become what? This is in the form of a plus b multiplied with a minus b, the denominator. Then this becomes a square minus b square, which becomes 7 square minus root 3 square. So this will be 4 plus root 3 multiplied with 7 minus root 3 divided by 7 square is 49 minus root 3 square is 3. So there you go. We have rationalized it, right? Thank you, Jay Gulati, for the comment. Yep, so I'm going to leave the multiplication to you because I know you guys can do that multiplication of both these terms, right? All right, so Jitendra says his name is Piyush there. Welcome. So look, we have rationalized the denominator there. So from the denominator, we have removed the square root and now the denominator is going to be 46. 49 minus 3 is going to be 46. Yes, multiplying and dividing with the conjugate of the denominator, Arudima, yes. How did 49 come? 7 square, Aditi, 7 square. 7 square is what? 7 multiplied with 7, 49, right? We are multiplying these two. This is in the form of a plus b multiplied with a minus b. In the place of a, you have 7. In the place of b, you have root 3. So it will become a square minus b square, and that's going to be 7 square minus root 3 square. It's okay, you know, if you're weak in math, but you like math, that's more important. Okay, because you are ready to give in the effort to learn. Good, you've understood it. Come on, let's move on now. All right, so these are going to be some of the last topics for this, the laws of exponents. I'm sure you guys know this. A to the power m multiplied with a to the power n is going to be a to the power m plus n, right? Anything to the power 0 is 1. A power m, okay, a to the power m whole to the power n is going to be a to the power mn. And anything raised to the power minus m is this, a power m. So these basic rules, I'm sure you know this. Let's take some examples now. 2 to the power 3 multiplied with 2 to the power 5 is going to be 2 to the power 3 plus 5, giving you 2 power 8, right? 2 to the power 3 completely raised to the power 5 is going to be 2 to the power 3 times 5, giving you 2 power 15. There is a perfect logical explanation for this as well, okay? 2 to the power 0 is going to be 1. 2 to the power minus 3 is 1 by 2 to the power 3. I'm just applying the rules. That's all I'm doing here. Nothing fancy. So, and then lastly, 2 to the power 9 divided by 2 to the power 5 is going to be 2 to the power 9 minus 5, making this 2 power 4. Okay? I can explain this by visualization. We'll do this sometimes later because we're running out of time. Yeah. Because this was a lengthy topic that I had to revise. All right, so come on, go ahead and match the following. So let's just say this is A, this is B, this is C, this is D, and let's just say this is 1, 2, 3, and 4. So A is going to be what? A to the power 0 is going to be what? 1, right? We've just seen it. Any base raised to the power 0 is 1. So A is going to be matched to 4. This is going to be matched to 4. A power m multiplied with b power m. A power m multiplied with b power m. Notice the bases are different, but the powers are the same. So this is going to be a multiplied with b to the power m. So let's just say this is, all right, we've done a wonderful job here. Nth root of a, all right, the options aren't correct here. Fine, let's move on now. This part is not correct for this. Okay, so let's check these out. 1 by 27 to the power 3. This is in the form of 1 by a to the power n, which can be written like a to the power minus n. So 1 by 27 to the power 3 is going to be 27 raised to the power minus 3, which is going to be what? A is going to be matched to 2, right? I apologize about the last question. The options given to us were not correct there. Now 27 cube root. Cube root of 27 is what? 27 raised to the power 1 by 3. So it means B is going to be matched to 3, and it automatically means that C is going to be matched to 1. Well done. So 27 raised to the power 5 by 2. This can be written like 27 raised to the power 5 times 1 by 2. So we can write it like this. 27 to the power 5 completely raised to the power 1 by 2. Okay, so this was again a fairly simple thing. Identities of real numbers. So these are, guys, you can take a snapshot of this, or this video will any which ways be there. So these are some list of really important formulas. Now you have to remember that you can only add or subtract like terms, right? Because root 3 plus root 3, you can say this is 2 root 3, all right? But root 4 plus root 5, you cannot say this is equal to 4 plus 5. That's going to be incorrect because these two here are unlike terms. So you can add, subtract only like terms. All right. So it boils around this fairly simple formulas. And then these are all the laws of exponents. All right, which we have already covered up. Right. Awesome. Only these many identities. Yes, Rupa, these are the only basic identities that you have. All right. Nothing more than this. So if you guys have any questions now, we will go through any doubts that if you have from this topic. I didn't spend a lot too much time on the laws of exponents because we've already covered it in depth in one of the videos. This session was just to give you an idea that, yeah, these are some important laws of exponents and you should be able to practice quite many questions on the basis of this. Yes, these are the only identities which are there. How to solve x to the power 1 by z. Okay. Saurabh, can you show me that question? Just go up. X to the power 1 by z, okay, plus y to the power 1 by z, plus z to the power 1 by x. All right, so this here, you know, you can't simplify this further because I don't think you copied the question correctly. This can't be simplified further. It is going to stay as it is. Arunima, I'm answering your question there. Maybe you have checked the question out incorrectly. Because this is as much as saying 2 to the power 1 by 3 plus, let's say, 5 to the power 1 by 3 plus, let's say, 3 to the power 1 by 2. You know, you can't, because these are going to be unlike terms, right? So you can't simplify this. It's going to stay as it is. I'm assuming this is what you meant when you wrote there. Can you derive exponent identities? All right, look, let's spend some time. I'm going to show you one. You will automatically understand how you would be able to derive this. Okay, look. 2 multiplied with 2 multiplied with 2. How much is this? 2 is being multiplied 3 times. So that's the reason why we say 2 to the power 3, right? If you know this, you will be able to derive any exponent identities. Okay, if you know this, you can derive anything. So 2 multiplied with 2 multiplied with 2, you write it like 2 power 3. Now, 2 power 3 multiplied with 2 power 2. How much is this going to be? This is 2 times 2 times 2 multiplied with 2 times 2. How many 2's do you see here? 1, 2, 3, 4, 5. So 2 power 5. This is the reason why you add the powers. Okay? Because this is the reason why I'm talking about this formula here. Why a power m multiplied with a power n is written as a to the power m plus n. As simple as that. All right. Now, if I were to talk about the second expansion here, a power m whole power n. I just needed some space to write down. That's the reason why I moved here. Let's say I want to derive a power m whole to the power n. Why is it equal to a to the power m multiplied with n? Let's check this out. 2 power 3 whole square. Let 2 power 3 be x. Okay, let 2 power 3 be equal to x. So this can be written like x square, and x square is nothing but x multiplied with x, right? In the place of x, substitute 2 power 3. So this becomes 2 power 3 multiplied with 2 power 3. You've already seen this, right? This is nothing but a power m multiplied with a power n, and this becomes 2 to the power 6. So this is how you can derive pretty much all the rules of exponents that you've seen. How to plot root 6 is what Brajesh Kumar is asking. How do you plot root 6? Okay, look. Root 6 is going to be what? Let's look at the right angle triangle. If root 6 is the hypotenuse, then the height has to be 1 and base has to be root 5. All right. So first you would need to plot root 5 and then you'll be able to plot root 6. That's the reason why I took you through this spiral method. Look, if you are able to see the vertices perfectly well, that's fine. Look, it all starts with root 2. Let's say this distance is 1 and this distance is 1 as well. Then AC, as per the right angle triangle Pythagoras theorem, AC becomes root 2. Now AC is root 2, CD is 1. Then automatically AD becomes the hypotenuse, which is root 3. So AD is root 3, DE is 1, right? Then AE becomes root 4, root 5, root 6, root 7, root 8, root 9. Play with this a bit, okay? Play with the spiral method. You will understand what I'm talking about. Just remember the height here is going to be 1 every time. That's about it. Root 9.5, you need a different methodology for you to be able to do this. 1 by y square plus y square. 1 by y square plus y square. If it is different, I don't understand. Is it what? 1 divided by y square plus y square? Then it becomes 1 by 2 y square. You first figure out y is given, right? So using that, you figure out y square and then you substitute it here. You will get the answer. Okay? All right, guys. If you have any other doubts here, I will tell the team to give you a Google form. All right? And you can post down all of your doubts, and maybe we will do a doubt session for you next week, because there are plenty of questions, as I can see, out that you have. And unfortunately, in these type of sessions, time unfortunately is not that enough. So I hope I've guided you well. Again, for students who have joined this, again, this becomes the heart and soul because you have somebody to answer your doubts, like you have seen here. Right? Even though I have explained you the concepts really well, is what I assume, you're still going to have doubts. That's a natural process. You should get doubts. If you're not getting doubts, it means either you weren't listening or you weren't thinking too much. You're getting doubts, it means you are on the right track. And this is where this whole idea makes a lot of difference, because you have somebody to answer your questions, personalized and one-to-one. There are no distractions. The tutor will be completely focused on only your doubt. And lastly, there is a scholarship test that we conduct every Sunday. I'm sure you are aware of that. So, again, the link to this would be in the descriptions box, and you find a good chance to get some really good scholarship on the BYJU'S program. And now comes homework time. This is going to be the question: 64 raised to the power 2 by 3 divided by 16 power 1 by 2 multiplied with 4 raised to the power 3 by 2. You can solve this question and let us know what the answers are in the comments box. And as you guys know, we've got you covered, of course. And this is going to be the last bit. If you guys like the content that we're providing you on a regular basis, please hit the like button. It will mean a lot to us. Share it with your friends as well. They may find it useful when they're revising the complete chapter. And lastly, hit the subscribe button in case you haven't. Most important topics from this chapter are going to be rationalizing the denominator, all right, and the rules involving exponents and powers and the various identities. Do not worry too much about plotting irrational number on a number line. It's very simple. Once you understand the Pythagoras theorem, height should always be 1. Based on this, this is what you're looking to plot. Hypotenuse is what you're looking to plot. If you want root 3, hypotenuse is root 3. If you want root 5, hypotenuse is root 5. So then, based on these two, you are deriving the base. That's it. I understand you will have doubts at this point in time. It's quite natural. Just put the pen on paper, try this method out, and I promise you, you will get it. All right? Awesome. Thank you for your time. You've been an amazing audience as usual. Some of my favorite students out there who regularly type answers in the comments box, try to engage with me. It's you who make these sessions so wonderful. So thank you for that. Take care of yourself. We'll catch up in the next session. And as I said, the next topic is going to be the next chapter, which is polynomials. Till that, take care. Bye-bye.